Good morning, good evening, good afternoon, depending on where you are. Today it is 16th of September 2024, and this is another instance of SIG Apps bi-weekly calls. My name is Mate, and I'll be your host. We have announcements. Yes, I forgot to put the announcements over here, but the big announcements are, and I need to pull it up quickly. Cube 132 release. I'll drop that in the agenda. The important dates for 132 release are the production readiness freeze is on October 3rd. So that's over 2 weeks from today. And the actual enhancement freeze is happening a week afterwards on the 10th. So October 10th is when you want to have your Kubernetes enhancements proposal merged. If you need to have your issue for your cap tagged for the 132 release, feel free to reach out to myself, Janet, or Ken, as we are going to go through all the reviews for all the SIG apps. The next important date out of those is the code freeze, and the code freeze is happening a month after the enhancement freeze, and that is November the 7th. The full schedule is in our agenda that I've also shared in the meeting chat. So you can poke there. I'll make sure that those two important dates, so the enhancement freeze and code freeze, are also in the meeting notes after this call. I forgot to do it before this call. So I believe that's the only important announcement at this point in time. Ken, Janet, is there anything else we want to add in the announcement section?
No.
Okay, cool. If that's the case, we can jump over to the main topic, which is the follow-up on the evacuation API. Philip, go ahead.
Yeah, sure.
I need to make you a co-host so that you can share your screen. Now you should be able to do it. I'm not sure if you want to share all three of screens, but I see Zoom on the left, your browser in the middle, and there's a dock on the right.
Yeah, I need to switch it.
You should be able to pick just one screen of all of them. There's a new feature, at least in the recently updated Zoom, from what I noticed, that allows you to share a dock. I have no idea how this works, haven't tried it yet. I doubt that it will be the one that you want. Philip froze for me. I'm not sure if he stopped sharing or did we lose him? I see Ken moving, so I believe I'm not the one that we lost. Yeah, it looks like we lost Philip. Okay, China confirmed.
Okay, so it crashed my Zoom. so, so let me try again one more time.
Okay, I made you a co-host. In the worst case, I can try sharing my screen, although, like I said, I'll only see like a tiny little piece of my screen. Yeah, we can see your browser and the cap that you're showing only. But you're muted.
Yeah, great. Yeah,
Oh,
I'm
now I hear you.
I'm just using one screen now, so it works. Yeah, okay. So yeah, I would like to follow up on the last discussion we had a few months ago about the evacuation API and mainly the alternatives. So we were discussing internally some designs by Ravi, how to actually extend the current APIs. I mean the PDBs, the disruption controller, and the eviction API. So yeah, I'm just now. This is not important for this. This is just the evacuation API, but I will go into the doc if we need to. Or I can actually show the section on the enhancing body disruption budgets. But so like one of the alternatives instead of introducing a new API is to actually have like when you make an eviction to actually consult other services. So we could have for example, like some set of URLs which we would contact before we make the decision for the eviction. And this could tell us or could change the information about how many pods are healthy and how many are not, and how many pods we can actually evict. So, like, I think one of the main problems with this is actually like changing the eviction API behavior, which would mean that right now, as it stands, it's like when you contact an eviction endpoint, it's expected that it will result in the termination of the pod, or if it is guarded by the PDB, that it will fail. But this is so we do not have like any like there are not expected any like side effects on this. So it's actually it can be known before what happens, and some of actually some drainers actually use that, and they read the PDB information before they try to evict the pod. So, and like one of our main use cases is like to have some asynchronicity in the API. So we could actually have pods that cannot be evicted for a long time, but we want to start the eviction or the process and actually wait for them to complete before the process is finished. So yeah, so that's one issue is changing the API. So other issue is like a performance issue. If we actually want to contact multiple endpoints when we are doing the eviction, and the whole like the whole package of failures or different failures we might be getting like from these side effects. So we would need some ordering of these endpoints, and then we would have to define the API on the person doing the request for the eviction. So there would be a bunch of new behaviors for the eviction request. So one thing that happens today is that actually people are doing this already. So we have like there are some components in the ecosystem which actually create validation webhooks for the eviction resource. And when the eviction occurs, they actually fail the validation and they deny the request. So this works for on the side of the person or the component which wants to block the eviction. but does not work on the client side. So you will get failure of requests of the eviction request because there is no well-defined API. And for example, when you fire up kubectl drain on a node, then you will see just a bunch of failures of the eviction and retries, and you actually don't have any clue what's happening. You just see that the eviction are failing, which could be also due to PDBs, but we usually promote that PDBs should have at least one replica that should be evictable. So when you debug the PDB, you can see the PDB has one replica that can be made unhealthy, and the rest cannot. So if you, for example, have a PDB that says that, or it does not have a PDB, or has a PDB which is completely blocking and has a min unavailable 0, then you actually don't know what's happening. You just see that the requests are failing. So like that's the one thing that the evacuation API is trying to solve. So, and if we introduce like these endpoints that can be called in this process, I think it's pretty similar to what we are already doing with the webhooks. It's just more well defined. So now I don't think like it's not like a supported behavior or expected behavior that the webhooks should exist, but that's the reality in the ecosystem. But with this, we would codify that you can actually override this, and we would have to come up with the new API for the clients of the eviction requests. So yeah, that's okay. So one issue is this, and another issue is that I think we are too much focused on PDBs. So PDB is actually the only object, like declarative objects, that enters the eviction process. And there are many other use cases where you don't need the PDB, and you could actually do without. So, for example, that's the one use case we are trying to solve with only when you have a application with only one replica, then a PDB in the current state as it stands, it does not support like one replica applications, so you cannot downscale and still be available. So we would like to have a upscale solution, so we can search one replica before we shut down the other. And one thing is that we saw that some people actually use these webhooks for the eviction to do some to use them as an aspect-oriented approach. So they have it deployed in the cluster, and they look through all pods which are evicted and may do some other actions on these pods. So like in these scenarios, it cannot be presumed that the PDB is actually there defined for each pod. So so I can give a word to some other people if you want if you have some opinions on these on the extension of the PDBs or the eviction endpoint.
I don't see any hands, but my main question in that case is because you walked us through problems and a potential solution, but I'm not 100% sure that I correctly understood. How would you like to address those problems with the PDB changes? I think that's the part that I'm missing. Can you roughly
You mean address
draw?
with what
Yeah.
address with what scenario? With
I mean, the question is more about what kind of PDB changes you're proposing to address the use cases that you're talking about?
So the use case is that you can actually have some decision made for like with the extension endpoints. You can there can be some entity making decisions what or how many pods can be made unavailable. So we are like this can contact like an external entity, and it's not this decision is not completely based on the disruption controller and the eviction endpoint.
Okay, so you're basically proposing to extend the PDB API surface with the ability to specify an external API endpoint that should be consulted to get the information whether this PDB allows or does not allow the disruption. Do I
Yes, yeah. So like
correctly?
yeah, this solution is not part of the CAP. This is just an alternative we are discussing also with Ravi. So yeah.
So that would be somewhat similar to in one way to writing an admission webhook that you covered. But the difference would be instead of um, listening on the webhook, you would basically have a entirely new APIs strictly for the PDBs. So my question is basically, if that's the case, we would be also that endpoint would be consulted about the information whether this particular, because normally when you specify PDB, you define the selector, you define whatever are the requirements for the API through min available, max unhealthy, and all that. If you would forward that to the external API, whatever the field would be called, would that endpoint would be responsible for giving you all that information so that you can then reflect that information in the status of the PDB, but also would be the point that we're consulting while evicting any particular pod?
Yeah, so I presume it would be on both places. When also and so the extension would be also in the disruption controller. So we would actually contact the endpoint how many healthy pods there are. So and to the same this would be done in the eviction endpoint. And like the API is not fully fleshed out, but I suspect that we could actually have different statuses returned by these endpoints and codify it in the API. What are the responses in the like when you make the eviction?
Mm-hmm. There are two additional things. I don't see any hands raised, so I'll continue talking. If you want to talk, just raise your hand. I'll be able to. I'll shut up and I'll give you the voice. You did mention that you would consider having multiple endpoints being consulted in the eviction. So instead of having a single endpoint, you are actually considering multiple, which I probably would say would not be a good starting point. I would probably prefer a single endpoint. And if there's a requirement that you have to specify, that you have to consult multiple, that should be handled in the aggregation should be handled in that single endpoint, just for simplicity. Because while you were talking, you mentioned that I believe you've used extenders or some or external parties as an endpoint. I would probably try to limit to only a single one, because the other downside of having multiple is that if one of those fails, how would you react? And that opens up entire field of how to deal with those. Whereas if you only have a single endpoint, you either get a clear information, yes, no, and if not reachable, then we'll probably have to figure out whether we allow the endpoint to respond within, I don't know, second. And if it doesn't respond, what would be the default action in that case? Whether we would act based on the last response, as in a cached response that we updated in the status, or whether we will be always denying because the endpoint is not reachable. That also has its own ups and downs. And the next question, well, that was a statement there, but the next one is a question. You did mention that we currently only return either the deletion succeeded or no, you cannot delete. Are you also thinking about expanding the status return from the eviction API to be a little bit more descriptive? I quickly poked in the code because I don't remember all of this stuff off the top of my head. The only two information that we currently, well, three, we return timeout, but that's a rare case. Usually it'll be either you succeeded or we will return a 500 with an information that that this plot is, well, yeah, that there are more PDBs. But that's
Yeah,
not
so
one.
Yeah, so I think we are returning also some conflict that can occur during the eviction and failure or success.
Yeah.
But yeah, regarding the endpoints, yeah, I agree. Like it's inherently problematic to have more of them and like to have like to actually handle the failures. But I mean, like one of the points of like doing these extensions is to actually allow the current use cases, which you have also with the webhooks and for the aspected approach. So like probably one endpoint would not be enough. But I mean like I think like the main problem with this so like what my cap is trying to address is that we would like to have an option to have the like this whole process happen asynchronously. So which this is not possible with just changing the eviction endpoint. And the asynchronous approach gives us more advantages. So we can actually have the process observable. So if we have the evacuation object, we can actually observe what each entity is doing. And as I said before, like today, when somebody is blocking the requests, then you do not have the observability. And like we would also remove the polling, because when you, for example, when you want to offload a workload from one node to another, you either have to first spin up a new workload on the new node, or in some cases you also have to transfer the storage, and this can take a long time. So in this whole scenario, like if we would expect the eviction endpoint, we would like have to poll every time if it is finished, or which is not fortunate.
I will admit that one of the topics and one of the concerns from the past discussion was the asynchronous idea of the evacuation API. I still kind of feel that a lot of the users already have a solution on their own hands that handles the asynchronous bit and the monitoring bit of the evacuation. I'm inclined to only extend the evacuation API with that endpoint, with the ability to specify the endpoint, and possibly improve the status return from the eviction to give you a little bit more insight at what state in the process you are. And then if anyone is interested in building their own mechanisms where they are observing the status, they could implement that on their own end. Because like you said, even the kubectl drain has retries implemented. I'm not sure how others are feeling about it. But that's roughly where I'm thinking about it from now.
I mean, but how do we want to solve the use case, for example, with the single replica applications or the requests where we got that actually people are complaining that, for example, the deployments have a max search field and they know that the deployment is is able to actually outscale during
but that would be
during the drain.
But if you so assuming that you are specifying an external endpoint that knows how to handle the draining of the application, the endpoint would be controlled, and during the first eviction attempt, it would be able to react and accordingly start the rollout of in that particular deployment of yours. And then upon a second retry, the eviction API, it would be able, or eventually one of the subsequent invocation of the eviction, it would be able to specify, yes, a new version is already rolling out, so I can allow you to destroy one of it. Although it would be a rollout, it would be more like a upsizing that application for the period of, I don't know, whatever the timeline will be between the rollout and the actual eviction of the older pod.
Yeah, so for this to work, like
It
one
would
of
be
the
it would be roughly similar to what we currently to some of the users that are already using the admission webhooks to listen to the eviction request, eventually react to them, and then retrying. The only difference for them would be that instead of specifying the admission webhook, which not every user is always capable of doing, they would be basically they will be able to configure an endpoint, which will roughly work in a similar fashion in the PDB API surface.
But in that case, like, but what you do when the application does not have the PDB? Like you don't have you need to declare the endpoint, but if the application does not have the PDB.
Oh, in that case, we're just basically falling back to the current behavior. If there's no PDB defined, then we allow the eviction to happen. So nothing would change from that perspective. It would only apply when you actually specified a PDB for your application. In which case,
Yeah, but
you either specify manually and allow the current logic, which allows you to specify min-max and availability and unavailability, and all the usual stuff that we currently have in the PDB, or you would specify the endpoint, in which case whatever else is already there doesn't make sense, and you would only look at the external endpoint. Because based on what I'm looking, our current PDB does not have any required fields. All the fields that we have are optional, so we can easily add one another field, which would be external endpoint or whatever the name would be of that field. And it would be either of those.
yeah, I mean, like one of the advantages was that like this could change the state for the actual like users who have this in clusters deploy without the PDB, so they would actually reap the benefit of overscaling the workload during the node drain, which is not only applicable for the deployments but also for the HPA and other like scale solutions.
But that would still solve because you're still consulting the external endpoint, and the external endpoint would have to be connected with the application such that it would know how to react to this particular application to read the number of replicas in case if you're dealing with a deployment that is managed by an HPA, or it would know how to deal with a single pod replica application, or it would also be able to read the status of whatever else I can think of.
Yeah. So like one thing is that it could be possible, but the users would have to define PDBs for applications they don't have PDBs yet, which is some hurdle, but it's doable. But if you, for example, want to offer this logic for the deployments, for example, by the kube controller manager, then the users would also have to specify the endpoint for the kube controller manager to actually contact it to actually scale, which I'm not sure is a good idea.
Why would they specify an endpoint of the kube controller manager? What I've meant is you would specify an external endpoint, whatever and wherever that application is running. That's out of the discussion. But basically, that endpoint would know that, oh, this is my app, and my app has to have just one replica. But if someone is trying to evict it, that's a sign that I should probably upscale it to 2. And then eventually, once the rollout finishes, and you again reach the endpoint, you are able to say, yes, you can now evict that other pod or not. And in a similar fashion, it would look at the HPA status and know whether the app was upscaled or downscaled. And basically, we would be embedding the entire logic for eviction in the external endpoint.
Yeah, so if we want to,
I believe is not that much different from what a lot of our users currently do.
Yeah, like I don't know, like it's a kind of a barrier of entry to define this by each user who wants to use this logic to have their own endpoints. Like for example, in these issues, we got requests to actually enable this like by default, and also this one, yeah. And like one of
Can you go back to that last one?
Yeah.
Issue. I mean, so yeah. So here's the thing, like when you're trying to communicate disruption tolerance for intentional disruption, like which is what the PDB is meant to capture, and then you try to, I mean, I guess my question is, are we over optimizing for this use case where it's like I want to have one of the thing and then say never delete it?
Yeah, so basically it's not the pod disruption budget anymore. It's like pod disruption budget and upscale.
But there, yeah, it's not a budget at all, right? Like you're saying, like what you're declaring to the system, your declarative intent is that I have a deployment with one replica and I have no tolerance for you to delete that replica. So like from the implementation of the eviction API, that's sort of like a works as intended condition based on what you've actually specified. I think encoding an ability to auto scale prior to eviction is what we're really trying to do to say, well, that's really what I mean. But I'm also willing to tolerate under some condition auto scaling in order to tolerate, an unintended or intended disruption? I mean, the simple answer is like have two pods, right? And tolerate one down. Like if you have two replicas, I mean, there is an additional pod there that, like, if you're talking about cost efficiency, right, that could be to some extent challenging. But if you can say, I want two replicas of this pod, and then when the eviction API comes around, you will be able to tolerate it.
Yeah, so that's true. But like there are use cases where this cannot be done. For example, when you have a pet application, for example, a virtual machine, then you cannot have two instances, and you need to guard against the disruption.
Sort of a thing that I deal with presently. And I guess like at that point, if you have a bunch of applications where you're basically not willing to tolerate any disruption because they can't be replicated, like in effect, like any unintentional disruption represents an outage for it. You can't do like a rolling update to do it. You just have to implement like a maintenance window-based custom orchestration in order to like gracefully delete those. And ultimately, like, if it's VM, it's not like we're doing, RDMA page mapping to another node where you can actually have a brownout and do a hitless upgrade anyway. You're going to take a hit. The question is, how much of a hit do you want to take?
So I think like it's also possible to not take a hit. So you can actually do the live migration of the VM. So you can actually migrate it while it is running to another node.
At a pod level, like, are you talking about a VM that's in a pod, or are you talking about I'm running a virtual, like I'm running on top of VMware and I'm going to do live migration and move it to another node?
No, I mean like a VM running in a pod.
How would you do a live migration for a VM running into a pod to another node? Like, I mean,
So
Creo has some of that functionality, but I've never seen it actually implemented at that level. And my understanding is currently state of the art for being able to, for that type of functionality, is really for forensic analysis. Like, we're saving off all the pages of a pod in order to be able to like take a look at what was in it later. We don't actually have any, like, in terms of the API ecosystem for the built-in components or Kubernetes capability to do live migration, unless we've come a long way there since the last time I looked.
yeah, so actually like that's like one of the issues which this cap is solving. There is also like a use case by KubeVirt, and they actually do that. So they have the live migration option there, and they are also overriding the webhooks. But I mean, also like this is not only for the VMs, but like when you have like also for other applications that do not require two replicas, then so for example you have for example some one load balancer or something, and you don't need two of them, then yeah.
Yeah, so I mean, I guess I'm not super opposed to something relatively simple like a scaling hook that would say, okay, the node's going down, you need to scale up, like providing that type of a signal.
Okay, so like I mean for the basic use cases where like people would like their applications to be actually automatically scaled up without them doing anything, that would not be possible. They would have to go into the weeds and apply the endpoint themselves, like to wire it to their application.
I think the tough thing to infer here is what a replica equal to one demands from the application, or why it's set to one. If it's set to one because you can't run two simultaneously because it would interfere with the application's operation, that could be a problem in terms of gleaning why the disruption budget is what it is and things like that.
So
That was also one of the reasons that I would probably lean on the application owner to provide you with more information about that rather than us trying to figure out how to scale up or down, how to treat the application, because a lot of that knowledge will be dependent on what kind of application you're dealing with. You'll deal differently with any kind of like stateful set database deployment, and you'll deal differently with simple web apps where you can just kill up and down in whatever direction. You'll deal differently with an HPA controlled application because there you need to know what is the current availability and then, I don't know, look at percentages rather than the actual numbers. And even though
Yes.
we don't have those capabilities, I believe, although I'm not sure if we don't allow specifying min and available by percentage. We do actually, both min and available and max and available are
Yes, so,
enforced values. But then again, I would prefer we'll leave that sophisticated knowledge embedded in the external endpoint if a user is interested in doing this. And if not, and they are completely fine with the simple behavior of the PDB that we currently encode, that would be a good starting point.
yeah,
That would allow basically. Yeah, go ahead,
sorry.
Ken.
But I was gonna say, I think I agree with like the challenge is this, right? Like if we try to encode one behavior, we're making the assumption that this is the uniform behavior that everyone wants. So like I think ruling some things out that we're not gonna handle is instructive. Like if you're talking about like pod-like VMs, the hooks for migration at the CRI level aren't really there yet. So I don't think we should go in and try to solve that problem off the door. If you're talking about like, let's say structured storage solutions, I mean, the advice that we usually give if you're running like something that's like uniformly replicated and strongly consistent, like Zookeeper or etcd, if you want to tolerate disruptions, you need to always run more than one. And if you don't, then like if you're only running one of them, then don't put a PDB on it, right? You can look at like structured storage with replication topologies like a RDBMS. So like think about Postgres or MySQL. But if you want to tolerate disruptions again, then the advice is usually, do wall shipping or do logical replication to a secondary instance and tolerate the disruption by getting hit. And now you're really dealing with like a stateful set situation most of the time. Non-uniformly replicated things with like anti-entropy read repair, like think Cassandra, like wide row column store that provides base level semantics, right? Again, like if you want its eventual consistency in your replication strategy is kind of on a per column family basis or per table basis these days, but like you can structure the application to tolerate the level of disruption that you want. It's harder to have a disruption budget for something like that, but you can do some reasonable things. Again, it should never really be zero. So then if you have stateless serving applications and you want to say, I just want one pod for this stateless serving application, and it's important that it doesn't go down, you're making a trade-off you're making kind of a trade-off between availability and cost efficiency, it seems. So how much effort do we want to spend on that, right? Like if it helps people to have some type of an arbitrary webhook where you can encode whatever semantics you want in order to scale up so you can achieve better cost efficiency for stateless serving applications, I'm not like opposed to that, but it seems like I'm just not as convinced that PDB is as troublesome or as broken as we're kind of making it out to be.
It definitely has its own limitation, but I'm not sure that I'm convinced that they are such a big showstopper that we would have to suddenly allow various expansion points for it. I would prefer we try slowly expanding, see how the problems that users might feel are being handled, and then eventually, if we decide that those solutions that we currently have are not sufficient, we can go a step further and potentially I don't know, expand the API servers furthermore. But I'm
Yeah,
pretty sure
so
that, especially with the recent additions, like we did um, with the healthiness of a PDB, that was actually a good step forward. So I think that one step at a time approach would be also in line with, I believe, what we were talking a couple weeks back about the stateful set. That let's not try to address all the possible use cases that people can come up with, and rather go one step at a time and see where that gets us. And then
yeah,
eventually we can reconsider again.
so can we go over this one use case more? So this is about the HPA. I actually talked with like SIG autoscaling, and they said that they would like this logic to like actually exist. So with HPA, there is like a problem like that the HPA scales according to the application demands. But actually when the demand is low and it scales to one replica, it's the same issue as before. But the user, when it setups like an HPA, they don't expect like there will be disruption because they expect that this will autoscale. So like in that case, like you cannot actually define like a standing PDB because the scale of the application is changing every time, and when it goes to one, so these applications, if they are without a PDB, that then they will be disrupted. So like I mean, for these use cases, it would help to actually have such extensibility.
Yeah, I mean, I like the idea. Again, having encoding very specific behavior that's encoded in the API and pushing it forward, and knowing that we're going to have to GA it in like 2 or 3 releases, I think is very risky. Allowing a very minimal API surface that has the ability to embed rich functionality that's very specific to each use case and that people can take and do what they want. I'm a proponent of that, right? Because don't want to be a blocker to progress, and it kind of allows people to go in, implement a lot of these plugins. If it becomes a popular feature and we build like, if we have a Volcano, like which is a scheduler plugin version of these type of APIs that become in common use, we can adopt it. If it doesn't pick up, that's fine too. For this use case, though, again, I don't really think it's that special, right? Like the main problem with HPA a lot of the times is the ability to scale to zero, which we don't do. And when people say I can't scale to zero, I really sympathize with that. But if like, I went to scale to one, but I want to have a disruption of one, like, okay, like why would you not set the minimum amount of scale? Like typically for applications that are high availability that I'm running across multiple failure domains, the minimum I want is like 1 pod per failure domain, just because if I get an unintentional disruption or if I have a long running zonal outage, I'm not beaten up, right? So this is somebody who's saying, I really want to scale down to the minimum amount of pods that I can possibly have, but I want like a scaling pressure based on disruption as well. That's an advanced use case. I think we should do that, but I don't necessarily know that there's a good way to encode that directly in the API that I have a level of confidence with, where I'm like, this is the thing. Which takes me back to like, yeah, like the idea of like having an arbitrary API endpoint that you can call into as part of the process in order to trigger a scale or whatever other semantics you need in order to manage a disruption would be my approach.
Yeah, so like I agree, like high availability is always better, and just channeling the requests of the users we got. So yeah,
That's not true. It's not always better. It's a choice, right? Because the more available, it comes with a cost, right? But
yeah,
you
true.
like trying to have both things is very, very challenging, right? Like I want it to be cheap and highly available is usually like, yeah, no, like
It's the picture where you have 3 ends. You can only pull 2 at a time. You can't pull all 3. So, and at the end of the day, that issue, this particular one, boils down to the other one where you were talking about single instance application. If the min available is set at 1, which is the decision of the application owner. But then again, if we go back to having an external endpoint, and that external endpoint would know that, oh, I'm actually at one, so I should not allow a disruption, but upscale first, and then only the subsequent invocation allowed, that's a feasible action. And that's why the external endpoint would solve, I would even say like 80% of use case, which would be good enough for now. And then we can return and consider any of those remaining use cases. What are the missing bits? Whether we should improve the API surface between the external endpoint with some additional actions, reactions, responses, or whether we need entirely new mechanism in the PDB API surface.
Yeah, so like two things. One is, so yeah, this would not support the aspect-oriented approaches, and they would have to be resolved by the webhooks as are today. And one is how actually to have this user friendly. So how would this be set up? Because, for example, when you have to the user, if they want to have like a basic logic, for example, the deployment scale or the HPA or some other service, they would have to find these endpoints, which can be changing. So probably some service. And if it is a good idea to like bring this networking approach there.
I'm not sure I'd be worried about the second part that much. So I'll leave it at that. But the first one, the aspect oriented approach, can you tell me a little bit more, or do you have an issue in particular that you have in mind?
Yeah, I can send it later. I had a discussion with one user, like when I was doing the cardinal maintenance, that they are deploying it in their clusters. So they are actually watching and reacting to all evictions.
Yeah, I would really like to learn a little bit more about that particular one, because I will admit that I have no idea what it means, aspect oriented approach. And like I said, for the application and the network, we've done that in the past in through webhook in the admission. We have API extenders in the scheduler. So I'm less worried about the networking effect of the eviction, even if that means that the eviction will be delayed, because both of the use cases that I mentioned a minute ago, both of them are actually in a critical path for ensuring that you have fast responses from the cluster, either for scheduling, although maybe a little less so, but definitely the webhook admissions, that's in a critical path for all the API responses and requests. So I'm not sure if that the networking aspect is that much problematic for
I
them.
mean, mostly like the user friendliness, and because like when there is a different actor who is deploying the extensions for the scheduler or the webhooks versus the persona who is, or the actor who is deploying the application, for example, the deployment. So like when you, for example, when you just deploy the deployment, then you have to find out the webhook and put it into your PDB. Yeah, it's more difficult, I would say.
I mean, you can always argue in both directions. But then again, the webhook also requires elevated privileges in the cluster to be installed. Whereas if we would provide an application with an endpoint, that actually allows the application owner to have a greater control over the app that they are deploying. Because then you don't, the the endpoint can be literally any kind of application, either running on the cluster or even as a sidecar container in your main application, because that's still doable in a single instance, because it would basically be the one protecting your pod.
Yeah, okay. So yeah, I guess like it's workable, this approach. So I'm still not sure like what will be the response of other folks of changing the eviction API. So I would probably like follow up with this and ask in SIG architecture what they think, if we can change the eviction API to actually return more responses and change the behavior during the eviction. So there will be actually more behavior or API on the client side of the eviction.
Yeah, definitely. That's a very good idea.
Okay, cool. Thanks.
Okay, right on time, like we're at the top of the hour. Thank you very much all for today, and see you in 2 weeks. Bye all.